share my screen and we can get going. Hi, my name is Andrew Welch, and I'm going to be presenting my project Atmos. Before we get started, I have a couple of acknowledgments I'd like to make. First off, this project was made in collaboration with Juliet Garcia. She's another computer science major. I couldn't have done it without her. It was also done with Dr. Laura Baker. Thank you so much. And then Dean Morris of the School of Natural Sciences was crucial to this project. So let's just talk about what we're going to do. So today we're going to go over a couple of things. So this project essentially solves a problem for another project that the school does. So we're going to go over a little background of the tropospheric ozone pollution project, which we worked with. We're going to go over our problem statement. And then we're going to review a couple of cool computer science-y diagrams. So we're going to go over the Marketecture Diagram, our use case diagram, our system diagram, and then we're going to do a brief demo. So the tropospheric ozone pollution project. Essentially what this is that Dean Morris of the School of Natural Sciences works with the larger atmospheric community here in Texas and then across the United States and collects various kinds of ozone data all over the US. So essentially they measure ozone concentrations in the atmosphere by sending up weather balloons. They're these little ozone sondes. They collect a bunch of different kind of information. We can see that here on the slide. Juliet, my partner, worked with Dean Morris as a student assistant on this project. She would go out, send up these weather balloons, and then helped collect this data. Dean Morris has been doing this for 15 years. They've collected hundreds of thousands of flights. So like I said, it's been around for, almost 2 decades. So the kinds of things they're looking for is that if they can track ozone in certain areas over time, they want to see if that correlates with decreased crop yields, increased risk of respiratory problems in those areas. So that's the general goal of it. Now, what we can see on the right hand of the screen is essentially the readout of one of these ozone sondes. So the ozone sonde collects a bunch of metadata, all right, here's the airflow on the unit, these kind of things. Here's the wind speed when we launched. And then it collects a bunch of different data over the 6-hour flight. So we can see that down at the bottom. So what are we doing here? So since 2004, we've launched over 1,000 flights in Texas alone. And the problem is Dean Morris came to us and he was like, oh, I have all of this data, but it's stored essentially on Google, on Box. So we have thousands of flights that are all stored on Box that are unsorted. So this is a really big problem, especially when we're trying to communicate all this really interesting information with the greater community. So we have all of this data that no one can really look at. So what we can see here is a shadow file. This is essentially a file format that's used by the larger atmospheric community that shows a lot of this data that we talked about. Now, the way Dean Morris was taking this raw data and turning it into a shadow file was formatted using a programming language, I think from the 1980s. So the way he was doing it was almost inaccessible by anybody else. And because of this, every station kind of across the US uses a different way to format their raw into a shadow file. So there's a bunch of inconsistency when trying to collect all this data. A Dean Morris shadow file might look different than a shadow file generated in Hawaii. And then we get to some of the written stuff. So in addition to the data that the ozone sonde collects, there's also pre-flight, mid-flight, and post-flight data. So essentially you'll have some kind of student unpaid intern on the site, and they'll write down on a piece of paper, okay, the wind speeds is this, temperature is this, and then they'll launch the flight and they'll take these kind of readings on paper as it goes. So they never actually digitally filed any of this information. All of this data for the last 16 years is in just a really big like file folder in Dean Morris's office on the 3rd floor of the JBWS. So we have all this really interesting raw data on Box and all of this other really important information ostensibly stored on paper somewhere. So that's kind of a problem. So Dean Morris approached us, myself and Julia Ursi, and asked us to fix this, essentially. So we came up with a solution where we were going to have a centralized web service that would allow a user like Dean Morris or any other person in charge of one of these kind of stations to be able to upload this raw data, have the system automatically convert it into a shadow file using a consistent method, let us automatically visualize those shadow files so we can see, over time, all right, the ozone has done this over time. I'll be able to compare it to data at other stations and be able to digitally upload the pre-flight, mid-flight, and post-flight data so that we can kind of keep all of this coherent and so it's easily accessible by other people in this project. Another cool things that we wanted to do is we wanted to be able to search by specific flights by station. So essentially, like right now, if I'm someone in Hawaii that has a station, I want to look at Dean Morris's stuff, I have to email him. He has to send me maybe his shadow files. I have to figure out how his shadow file compares to mine. It's kind of a mess. So we wanted some kind of very centralized system, just plug in a location and a date and be able to get back that consistent shadow file. So next we're going to talk about the Marketecture diagram. Essentially what this is a high-level non-technical diagram of kind of what we want our system to look like. So as we can see, we have Atmos. So we have our web application. And then we have, so essentially we have the concept of a flight manager, which is someone like Dean Morris, who will be able to send his data into Atmos using our web application. We're going to talk a little bit more in detail what that means in our use case diagram and our system diagram. So our use case diagram, we're just going to talk about the general kinds of users our system can support and the things they can do. So our flight manager can do, we have a flight manager and a system admin. The only major difference is that a system admin can do things like add additional flight stations, like someone who is higher up the chain in this project can add, okay, we're now collecting in Dallas, we're now collecting in Waco, and being able to add that so that other flight managers can now upload their data to Waco, to Dallas. They can also add and remove, a planned feature is they could add or remove flight managers just so that we don't have flight managers registering themselves or like me being a flight manager, stuff like that. Yeah, so register, removing, and viewing user credentials. So flight manager, they can log in, they can search flights by location, they can receive a visual display of flight data in a graph. This is a really cool thing that I want to talk about when we get to our system diagram. They'll be able to upload the raw data files. So this is like a .det, a .de1, a .raw, because the sonde generates like 5 or 6 different files that all need to be like formatted into a single shadow file. And then they'll also be able to submit their flight prep sheet. And then the system admin, they'll be able to log in, register and remove flight stations, search flight by location, be able to upload flights, and then receive a visual display, and then register, remove, and view user credentials, just so we can add, say, new flight managers, or say if we have Dean Morris as system admin, being able to add like student assistants who can now upload flights, right? So being able to add someone like myself or Julia. So our system diagram, this is essentially just real technical, what we're doing at each step, how we're doing it, how we're storing various kinds of information, this kind of thing. All right, so at a high level, we see we have 2 interactions. We have the interaction between the flight manager and our system and the system administrator and our system. So I think, yep. So the flight manager will be able to log in using HTTPS authorization. This is just a secure way to connect from a browser to a web service. Our web service will receive this interaction using Python. That's just what we built our backend in. The Python will be able to receive that request, say if I'm uploading a flight, receive that file, file it away in a common sense flight file directory. This is just so that it's easily organizable and searchable. And then we have something called the Elastic Stack, which is basically a cool NoSQL database system, which allows the easily logging, storing, and searching of files, and being able to easily and dynamically visualize them using something called Kibana. So this is just what is going to enable a lot of our visualizations of the data once we receive it and once we transform it into the shadow file format. And then on the other side, we have the same thing. System administrator will be able to interact with our Python backend, and it will send back whatever kind of information, right? We also have a MySQL database, which will store things like user credentials. So we're salting and hashing user passwords. This is just an extra secure way to encrypt them so that, you know, nobody can steal our passwords. Also be able to store flight prep sheets. This is the best way to kind of store that information just so that it's easily accessible and searchable. And then general station details. And then the entire thing is built in Ubuntu, which is just a Linux shell. We're using Nginx to handle a lot of our internet traffic, and the whole thing is hosted by DigitalOcean, which just hosts web servers like ours. So, project constraints. So if you can't tell by the fact that we are not in person, a couple of things have happened since the first time we presented this back in February. So our project was ostensibly done back in February when we presented for a senior seminar. And then myself and Juliet, you know, took a week off. We were like, all right, we'll get it working then. And then we got a little spooky email. So in that week after we ostensibly finished our demo, our droplet, our digital server that had all of our stuff on it, got nuked off the internet, essentially. So our DigitalOcean droplet, our server, was hacked into by a malicious bot, and then all of our stuff was destroyed by DigitalOcean to keep their stuff safe. So because of this, we lost a lot of progress early on. Myself and Juliet have worked really, really hard to reestablish a lot of this, and this project will go forward in the future. We're talking with other students who are going to take this project on, work with Dean Morris, and keep building on it next semester and the semester after that. So just a little constraint before we get into the demo. And now I have a brief little video demo just to show, you know, login, uploading and searching, and using the Elastic Stack Kibana visualization. So let's get into that. All right, so we can see our login page. Currently, this is now using HTTPS, which is a better, secure way. We have a little contact page. This is going to be worked on and built out by future people working on this project. So we can see we can, you know, add a name, add a email, send a message, and this should go to some kind of system administrator or a flight manager of that location. So we have our login. Like I said earlier, this is using the encryption method of SHA-256. It's just a way of taking that password and essentially transforming it so that you can't go from the encrypted password back to the raw. And then we have our user dashboard. So essentially this will do a couple of things, right? It'll be able to upload flights, search flights, and visualize flights. So we have our little flight upload page. We can select a file. It can be a .txt, a .de1. We can show here using Postman, which is just a method to interact with our backend, that we can go to that endpoint. We can upload files to our server, and they'll show up there. So this is just showing that we can send a file up onto our server, and it'll show up there if we search for it. And then here we have an example Elastic Stack Kibana visualization. Essentially what this is doing is it's reading in data that's currently that was on the server, and then dynamically rendering it. So just looking at, okay, here's all the data. Here's a bunch of little graphs that we've built. So the idea is that myself or the future team will be able to build these graphs, and that anybody who enters new data on those graphs will automatically and dynamically update so that no one needs to tinker with it. The other really cool thing about these Kibana things, if I select a piece of data in one graph, I can sort or filter other graphs using that single data point. And I think it shows that a little later on. We click one of the things, it morphs some of the other graphs. That is all I have for the 16 minutes I was allotted. Any questions?
Hold on. Okay, before we start questions, I want to bring in Dr. Laura Baker, your advisor and mentor, and let her address your project, and then we can go on to the questions. I think we have plenty of time here. The next presentation is at 4:45.
Hi, Dr.
Baker. Well, thank you, Georgia and Andrew. Good to see you in person again.
Yep.
I'd just like to talk a little bit about Andrew's project, and Juliet, of course, worked with him on lots of it. It was quite an extensive, large project with an extremely large number of data files that were quite unordered and hard to get a grasp on. So I think Andrew and Juliet did a very good job working with Dean Morris just to understand the initial problem he was having and what he wanted to do with this project. I think that's a very challenging aspect of these kind of projects where you have a client. The client knows what they would like, but it's very difficult to get the appropriate information from a client. And so I think one of the things that Andrew and Juliet learned quite well was you really have to spend a lot of time with clients and figure out what they really want. And I think that was quite a challenge, and good job, Andrew, and getting that done. The project will have a life beyond Andrew's graduation, and we hope to continue it. So I just want to say thank you, Andrew, for taking this on and for doing the big job you both got
Best
done.
we can.
Yeah, it was quite a challenge. It's more challenging
yeah.
than it looks on paper. It's understandably a mountain of work. So good job on it.
Okay, thanks. That's great. I mean, it's so impressive. It really is impressive. Does anybody have any questions for them? I'll mute and let Andrew handle it.
Hi, Andrew. This is Dr. Hauser.
Hi, Dr. Hauser.
Pretty awesome. And like Dr. Baker said, pretty ambitious, I think. I was surprised. So nothing like this exists at, say, the national level, like NOAA or any of those agencies that you would think of that look at atmospheric science?
So essentially, the project that Dean Morris was working on, they were collecting a little bit different information than NOAA was. We actually had a goal of, at the end of it, we could upload some of the data that was collected on our server to NOAA and NASA and these other kind of projects. That's a long-term goal that we have. But in terms of what Dean Morris is doing, really he's taking all this data and he's going to cities who are like over like federal ordinances for ozone amounts and being like, here's where it's coming from. Here's how we can see it transmitted from like this area over to the city. This was kind of the goal of that project. So there's a little bit of difference from things that like NOAA and NASA are doing.
Great.
Does that kind of answer your question?
Yeah.
Okay, cool. I see there's a question from Dr. Benham. Thank you again. Yeah, did this try your patience at all? Do you think it will make it easier for you to do this in the future? Yeah, like Dr. Baker was saying, the hardest part was really meeting with our client, meeting with Dean Morris, and trying to figure out what he wanted from what he said he wanted. That I think was the trickiest part, because someone will say, oh, I want X, Y, and Z, and then you'll do X, Y, and Z, and you'll come back and you're like, no, I wanted A, what are you talking about? So being able to kind of divine what they actually want from what they say they want was a really interesting, I think, really good skill that I got out of this project. That's probably the greatest thing I got out of it. So thank you for the question.
Can I ask another question?
Sure.
Yeah.
Can you explain a little bit? I think that your elk, cabana looks pretty cool, the graphic stuff. Can you explain how that works?
Yeah, so this is a tool we found. I found this like a year ago in my internship. Essentially, it has 3 different elements. That's what ELK stands for: Elasticsearch, Logstash, and Kibana. So the tool is originally built to go on a machine somewhere. The machine is generating a bunch of data, and the ELK stack will intake all of that data, transform it into a certain file format. Like, okay, I have a bunch of these log lines. I can format it a certain way so that it's indexable, so that it's searchable. Right. And then Kibana, you just set up a kind of structure for a graph or a dashboard, and that dashboard will constantly intake that information that Logstash is giving it and Elasticsearch is giving it and kind of give it form. So we took it a little bit of a different direction, because it's normally built for like constantly updating files, where we'll just like inputting essentially a big CSV of like 10,000 lines. So we had to do a little bit of trickery to get it to intake this huge CSV, transform it into a file that Elasticsearch could even read, and then making that thing indexable so that Kibana could visualize it.
Yeah, very cool.
Angel Fan's got a question. Thank you again, Angel. We've done this type of development for a client before, and what kind of things you're hoping to develop in the future using what you've learned for this project? So I think this and another related class with John Mulholland, Software Engineering 1 and 2, really kind of got me in the mind space for working with a client. Software engineering has you essentially working for the professor and doing some crazy projects for them. So I had kind of a feel for it, at least in a classroom sense. This was the first time I was working with like an actual person. So that was really, really interesting. And I'm really excited to kind of take this project and pass it forward to future students.
Okay. Wow. Thank you very much. Thank you for the excellent questions and for your participation. This is like a bright spot in the semester to see all these presentations. But